And now we started a relationship with BIMtech, so you never know what's gonna happen. And yeah, this is Amsterdam, a part of Amsterdam, an old map. And in the left, there was an old wood harbor where all the wood from Finland, where somebody is from Finland is here. We collected all the wood there into the water, and that's 100 years ago. And right now, it's a real big redevelopment area which is completely transformed to a new area of the Netherlands. And on the left, that's the project where we were involved, Pontsteiger, and that's where we're going to talk about. And Pontsteiger, Pont is like a ferry, and ferry dock. Steiger is a dock. And usually there was a ferry sailing to the other side of the large canal, so that's why the name is Pontsteiger. So there was no land at the time when we started designing it. And at the end, this should be the result. 366 apartments, and the top penthouse was the most expensive apartment ever sold in the Netherlands until then. So it was 16 million, and it was 1,450 square meters. It was sold on in Christie's in New York on some framing. So we pumping out of the water, drilling holes until 30 or 40 meters deep to a sand layer because we are living in a swamp. And we're making the foundation. And after the foundation, we built 1 week a story. Every week we build 1 story extra in the towers. And what you see is what all prefabricated elements who were placed on position. So around the building there was a road for trucks, and next to the tower cranes they just had 1 movement to place a whole wall with all windows and including glass and everything. There's also a spectacular bridge in between, and that's from steel frames. We made some steel frames somewhere else in the Netherlands. They were sailed with the ferry to the project. Not with the ferry, but a boat. And then with 4 bolts, or more, I think, for 14. And then, depending on the pressure, they know, okay, it's 20 meters deep or 36. And we have, like the towers, they have piles of 40 meters, and the lowest part, they go to the first sand layer of 20 meters. It depends on how heavy your building is. Also, my house is on piles, a small house. But that's only the west of the Netherlands. The east, we have some sand and some other soil. So now we're back to where we were. You see some steel framing. And there's this empty. And you see, you don't see welding outside. There's welding with the electrician to combine the steel frames. But it's all mounted with bolts. So in 2006, when I started to work at the general contractor, I finished my bachelor degree of building environment. Not educated as an architect, but I didn't even try it. Only my bachelor degree, but also good. And this was my office. I had a lot of paper. I had a laptop and some, not a mobile phone, but a phone connected with a wire. And this is how we worked. And we would use that we get paper drawings with some hatches. And depending on the hatch, we recognize, oh, that's the material, concrete or brick or something else. So that's what, does anybody learn this on school right now?
Yes.
Yes.
Okay. Yeah, we learned that also in school. In the middle is my dad's, his garage. And we collected all those papers and put them into a kind of a wall so that we can see what we're going to build. And this is a real project. This was a hospital in the Netherlands. And it was commissioning man, I don't know the English word. But in 2007, I had to renovate this building, or transform this building to a museum. It was an old place house. And inside the museum, there was a whole steel structure. And I was going outside for 6 months to measure what size the steel structure should be. And there was a big model, because the steel suppliers, they always make models because they cannot make the steel frames without the model. So it was the first BIM project. And after that project, there was another project for our company, which was not straight, only angled. And there we had 6 different steel suppliers for the main frame, for the subframes, and it was produced in different factories. So we needed to do something with BIM. And so we combined all those models into, at the time, BIMcon, I think. And I had to manage that project, that everything will fit on site. So I made a list of all the people who were working with us, and I wrote down at the end, the last column in Excel, which software they are you working with. So here you have a list, and Revit wasn't there at that time. Oh, it was there. Sorry. But we decided to use IFC. IFC is an open standard. It's kind of the 3D DWG, but with the information and some more structure, so it's better than 3D WG. And we were, at that time we were making comments with markers and some red lining, so to tell the steel frame how to work. And I tried a little bit into PowerPoint to make my comments, to keep it more digital, to just write it down in some arrows. And now we do it with BCF right now, but that's later in the presentation. And we do the quantity table in Excel. We just measure it on the drawings and we write down measurements that time. So it was BIM level 0. We have some BIM levels in the Netherlands. We have 3 levels, or 4 levels, 0, 2, 3. What do you have a question?
No, that will follow later on in the presentation.
Oh, that will follow later in the presentation. So that gives us a lot of headache, all those papers and how to manage all those different information. There it is all. Yeah, I knew that was coming. So we have copied the English BIM levels. We didn't even translate the word level. At that time it was level 0 with papers. Level 1, that people are started making models. For example, in Revit. And you have level 2, that it's integrated collaboration with BIM, that you focus on the model and that you combine them from all disciplines. And that was our focus, and you need open standards to do that. You cannot do it, Autodesk say that you can do it with only Autodesk, but there's more than only Autodesk that you can see in the slide before with all the software into one project. And the thing is that we prefabricate everything into factories. So this is a picture of a few weeks ago. So why BIM? At that time we were working with BIM for a few years already, and my CEO he invited me and he said we're going to do this project and we have some targets for the project. So it was company policy. We do everything in BIM, so we couldn't do it in a different way. That was my job. I was a BIM manager, BIM implementation manager in the organization. And we were thinking this building, you cannot build it without BIM. You cannot go welding on site and let's see what happened. And to save money, because we save a lot of money to do the engineering into the computer and not on the construction site. And it has to be built in 2 years. Because if there was no site around you, all the temporary stuff on the construction site, they cost money each day, cost a few thousand euros. So every day you save, you save some money. There was no working space on the site. It was a skyscraper, and we had an ambition to raise the information management in the construction in the Netherlands with the project. And yeah, we decided just let's use the current state of engineering. That's what is possible right now. That's what we're going to do. We don't look back for 20 years with drawings, just do it like what's already possible. So because we can. And prefabrication means that it has to be virtual first. Because only if it's virtual first, then you can see if everything fits. Because if you have a wall with a window and the glass already in the crane, and if it doesn't fit and it has to go back, the whole process stops. So all other trucks has to be stopped. So everything has to fit. So that was the most important thing. So we did BIM from design to manufacture and back. So the manufacturers, they're making the models, and the designers are checking if the model fits into the design. So, the BIM agreements.
So, we needed everybody on board. And therefore we needed to have some agreements. As Lex already told, we were doing the design, the engineering, and prefabrication with BIM. And because this building exists about 70% of prefabrication, all the subcontractors needed to be on board as well. And we didn't do that by ourselves. We made the team effort. Here you see Lex. It was a couple of years ago. That is visible as well. So we made agreements with the whole team. And we needed everybody to join in. So we couldn't force them, because when we force it, they won't do it, they just say they do it. We needed it to be a team effort. And we didn't invent something really new. We just tried to make the best of what is there. We didn't make Revit, we say use a good tooling. We didn't invented a new way of sharing information. We say, hey, let's use IFC. And that's some people already also ask us, what do you see for Romania? I think you can use a lot of the information that is there already. You don't have to invent. So these are the levels, and we said we needed to be, as a contractor, for we don't need only a model to get to the papers, to the drawings. We need to start sharing the information, sharing the models to make it fit. So we say, stand here. We need design models, and we have supply manufacturing models, and those need to be representing each other. So first we have a design, not only for design purposes, but also for the engineering, and is the floor going to fit, is the steel going to fit. And then the steel framing comes in, first digital, we check it, you see it later on in the slides, and coordinate it. So we call it the hamburger model, the best is in between, and that's the project. So we don't do it for an architect or just for one steel factory, and we do it because it's the best for the project. So on top is the architect, all the advisors, structural, building services, the engineering for the building services, and the lowest part is all the supply chain. And we as a general contractor, we are in between as well, because we have to coordinate all those models. So in the execution plan, we first written down why we do BIM. Because Simon Sinek, I don't know if anybody has heard of him, check him out on YouTube. He's a really good speaker, and he describes the golden circle. They don't do it They do it because why you do it. So first, why do we do BIM? Then, how do we do it? And then, what do we do it? So this was our contract with all the suppliers on what we are going to do with BIM. Because only text, nobody reads text. It's okay, thank you, I put in a drawing. So we made some more infographics about this is what the text is explaining. We have in the middle is the explanation of how IOC works, with the property sets, how property sets are in the model, and how this information then as output comes on a drawing. So how it's all connected to each other.
It's free to download somewhere.
Yeah. Because we work digital and the laptops are fast, but they do have a maximum capacity. We already in the beginning decided how to make batches of this project. So we have the green part is the basement, the low area, the towers, and the bridge.
For example, with the Parliament building, we decided how much pieces shall we cut it to let computer programs work with a aggregated model with all disciplines. Because it's probably impossible to get it in one model.
Of course. How many models do you think it will take for the Parliament building?
This project, at the end we had 335, but for
3,000.
I think 3,000. Maybe I split it in 10 pieces maybe.
We'll talk afterwards. How we do it.
But it's really important that you have a plan for this in the beginning, because when you start making your model, it's almost impossible to split it in the end, especially when you start making your drawings. And so it's really important to have a plan about how to attack your project.
Just the current state of the hardware and all the equipment.
Yeah. And even for all the BIM engineers, we made a mouse pad like leaflets. Hey, you are for the bouwkundig, that's the building engineer, and the construction engineer and the installation engineering. And we made special templating about which information we need in what property sets. And just telling this was not enough, so we put really a lot of effort into helping everybody. So we also made some instructions how to get a good model out of these software types, because it was really important for us to have those models for the coordination. I don't know the exact numbers, but 1 day delay on site is way more expensive than me driving to a vendor or a subcontractor helping to get the right model.
I think your whole year's salary will be 1 day on site.
Yeah. Maybe 10 years. About using the standards that there are, IFC describes not only it's not only an export button in Revit, but it's a whole structure about which information can be added or should be added to which element. So we didn't invented which information do we need and where do we want you to store it, but we say, hey, we want load bearing, we want to know if it's external or internal, and those are already predefined in IFC. So we in the next half of our presentation about implementing BIM in the Netherlands, we will continue on this, but it's already predefined, so you can just start using it. And only if you ask somebody what do you want to know about a project, what is the information you want, you probably will get, I think, maybe 200 lines of I want this information and this and this and this and this. But when we summon it, it's actually, you don't need that much information. You actually need only a small piece of information, because when I only have the quality of the concrete, I can already make decisions on when and how to pour it or how to optimize it. And you can of course how to color it. You can just filter it on the information. Concurrent engineering. This building was a team effort, and we needed to do that with the whole team. So even in the design process, we already contracted some subcontractors because they were really important for us in the way we make this building. So these were the design sessions. Everybody brings in their own laptop. We have a screen, and you can just start seeing the same thing. And that's already, if you want to know what's your business case in BIM, seeing the same building in the design phase is one of them. Structural design, MEP design, architectural design. It's split even in the spaces, the interior walls, and just the interior and the exterior. And you have to coordinate it. It started with, as the director already told, about the soul in the building. The engineering is still really good possible in 2D. I think even you have to start on this way. First you need to know what building do I make, how are the principles of this building, and then you start doing it in the model.
And here they decided what shape should be in the BIM model, and there they decided how do we split it in elements or in parts or in different materials.
Because not everything is in the model, and only the things that take size, it's in the model. So from a 2D sketch, we first went to make something like this, because it was still in the design phase. Everybody can comment this, and we went further on in the details. The facade is all tiling, even the tiling was prefabricated, so we needed to decide in the design phase which tiling or which spacing was necessary and accepted by the architect, because they don't want to see the spaces between the tiles, of the elements. And so on and so further, because all the prefabricated parts were in the 2D world. Sometimes you meet a co-engineer from another firm when the building opens. In this case, you work together and you meet up front, and that helps. So you know who is on the other end of the line, and what insights, and everybody brings their insights in the engineering systems.
Mr. Kober, yeah, sorry.
A short question, did you actually share the model at the same time when you were working there, so you had something like a one model, or did you have a federated model, meaning that somebody worked and then you upload it, somebody upload it back?
And we had two different things. We were sharing all IFC files on a kind of common data environment where we share all the files. So not sending by email with a WeTransfer or something like that. And we also had, for the designers, we had the Revit server. So we had a server system that they were always linked on the two systems. And for the suppliers, we didn't use the Revit server because they don't work with Revit. For the time, we have a half an hour right now, right? So we have to keep a little bit more system.
Okay, I will keep it.
Thanks for doing my job.
So this is the way we decided to make the models, and then we have the models, and then they need to be coordinated. First, they need to be checked: are they correct? Are they made according to the agreements we make? We need to say this is the coordination system. This is the starting point. Is everybody using the same thing? Otherwise, it won't combine. Uniform classification is also already mentioned. We have to classify the building. We need to have everybody make windows as windows and not as doors or as something else that was just easy. And is the information in the model as we agreed upon. Then we have to check the design. Are the design models correct with each other? Is the architect making the same building as the construction engineer? Or is the MEP engineer designing something else? So we class structural buildings, structural building services, structural architectural and architectural building services. So you need to, then you know that it's one building and it fits. So this was the design, and then when solving these kind of errors, we can start using the models from the suppliers. Because we know the engineering is done right, you have to make these doors, and then I will check if you made those doors. So here's this design model. So this is from the structural engineering, and this is the model from the supplier. So we can check if it fits. If the supplier didn't deliver the wall, so that you won't see it. But if the supplier's model fits within the floors of the structural engineering. Or the windows, as we discussed in the design sessions, should be made like this. This is what we get from the manufacturer, and we can compare those within each other to see how it fits or where it doesn't, and we have to act for it.
So it's not only clash detection, it's also match detection. Is it the same?
And then the last check is the suppliers with each other to make sure that those overlap. And then this is why we do it. We want prefabricated, correct on site. An anchor in the model is an anchor in the project. There as well, because it was on the crane, it needs to be there, it needs to be bolted. Even the holes for those anchors were prefabricated, so there was no drilling also. That's also good. This is one of the footings on the bridge. So you see, it could not, if it was wrong, we had a big problem. And it fits. And you see also that it's prefabricated steel on prefabricated steel within prefabricated concrete on the angle.
So how did we organize it? We have a knowledge map in the Netherlands about the BIM roles, like the BIM, what is the BIM modeler, the BIM coordinator, the BIM director, and the BIM manager. We were the BIM managers. We had several projects. And on the construction, on each project, you need BIM directors. And we had 2 BIM directors because of the size of the company, and also both companies wanted to learn a lot about BIM. So they decided we need 2 from both companies, 1, because we're gonna have a lot of
Next year we'll bring those guys.
Next year, if you want. Yeah. Yeah, that is possible, I think. But they still work in the companies, and those companies, they don't work internationally. We discussed that.
Okay.
Or you should visit with a team the Netherlands, and I can tell you several projects where you can learn. I think it's a trip. We're going to do some traditional things in the Netherlands, but we just mentioned.
Okay.
Okay, so we need a lot of collaboration, so it's working with models, not only software. And of course, we had a lot of issues. We managed them to look at the models and make some BCF files. We have different issues like clash detection, but also wrong positions, or even doors which should not open because there was a steel frame behind that can be checked with, for example, Solidly. We managed all the issues with BCF, so not with screenshots in PowerPoint, but with BCF. And with BCF you can get rid of all those red liners, and you can communicate with other software. And the modeler, for example in Revit, he get an issue from me working in DDS-CAD, and he will zoom into the right position in his software. So you should use BCF too. And we had BIMcon to manage all those issues. We had 6,000 issues, and they were all solved. And this is a screenshot of the BIM modeler, and he was happy that he can navigate directly to the issue. And this is a screenshot of all the building facilities, the installations, even floor, heating, and everything is in the model. And to get all those installations into a prefabricated building, you need provisional voids to make the holes into the walls and floors, because we don't want to drill them all on site. So we had a model of every discipline with their provisional voids. And also fire rating is really important, that all walls have the right fire rating, and you can show that quite easy with colors if you look into the model. These are the piles who are drilled down. On the right you see really long piles of 60 meters, 40 meters, and then are 20 meters. And how much are the total? It's not here, but I think 1,200, something like that. And this is the quantity takeoff for doors, quantity takeoff for all spaces. Actually, a client that buys spaces, and we need a wall between spaces, but actually they want spaces. So this is the most important calculation for a client. And if you have the area, total area, you can do it times, I think, 5,500 euros for each square meter for an apartment. So if you have an apartment of 100 square meter, you pay 550,000 euros in the building, approximately. And here we simulated one piece of tower, one cycle. And you see all the temporary stuff is also in the model. This is called, you can call this 4D. You see the temporary scaffolding, safeties. I think that was once. Oh, you see the ceiling right now around it. Yeah, next story. Because you have to tell the truck in which order it should be on the truck, because it's the wrong order. You have to put one to the side, and then it takes a lot of time. Here we see the total with all the temporary scaffolding and all the. It was one software we almost handle all the models. We had to continue because we have 15 minutes. These are the prefabricated elements. And here you can see that they were with trucks and boats. They were bring to the construction site, and with large cranes. First virtual, we position them here, and then it should be there. And each step can be analyzed so that things cannot go wrong. And here you see the connections. It's actually 2 bolts, but it's one on this side, and the other one has to be with small hands from the other side. And also we combined different models to one element. You see all the elements there in the north of the Netherlands, and they came by truck. And you can see they're on the platform, which is loaded from the truck. And on the right you see the element is positioned on the building. So now we built an icon for Amsterdam, and we did a lot of site support too. Jasper?
Yes, this is part of the simulation, the site support. So we didn't have a building site because the building was the building site. We needed to simulate where to put things. If you know what the volume is of an element, and you know the weight of an element, and you know the distance between the crane and the element, you can calculate if it's possible to lift or not. So we had to adjust some of the elements to make it possible. And even those constructions, how to bolt the crane to the building, is really important in the flooring in this structure. As you've seen before, we modeled all the
Trusses?
Props
and aprons.
when this building was built, there were not that many trusses left for the rest of the Netherlands. There was no scaffolding under the bridge because it was too high, so we made a bridge under the bridge to work on. There was a hanging platform. It was also designed, modeled, in use. So we think. So level 0, there's no BIM. And here you're climbing up to level 1. I think maybe, no, and define for yourself, where are you? In level 1, people are making models for themselves. So an architect makes models because it's really good tooling to have correct drawings. A structural engineer makes models for his drawings, steel engineer as well. Next level is combining those models and have the discussion in engineering with those models, integrated models. When you start having good models, you can do really good quantitative. If you do quantitative on bad models, you get a bad quantitative. You win the project but don't have the benefits. And the next step is to have some kind of interconnected BIM. I place a steel column and the steel manufacturer knows he has to bring the column, or I know this column is not available, or something like that. We don't know. That's in the future. So for when do we start? When do we need to start? What do we need? Do we need a client that demands BIM? We think no. Just start. Everything is there. The software is there. The tooling is there. There is enough standardization already. Start. Because when you start to learn. And when you learn, you have to do things like this to share your experiences. Because you can only start scaling up as a nation or organizations if you share outside of your office. If you are the only BIM manager in your office, you can only learn for yourself. And you can learn faster with somebody else. So our just quick steps was in 2009. Item is make agreements about your coordination. What's your origin of your project? The second one is mark it, so it's visible. Otherwise, you cannot check in your model easily where the origin is and what the displacement is. Then we have some agreements about what kind of material that you need to identify material. It's not only a wall, this wall is of concrete or wood or
So one addition, we also have a material passport. If you upload your IFC file to a kind of system, you can see the sustainability of the building. So therefore you have to have in every object material so the computer can analyze which materials are used in this project.
You have to use the right entities in IFC for the right things. For example, what's the surface area of the floor? It's the area where you walk upon. What's the area of a wall? It's not the same area where you walk on, but it's the area that you paint. But if you use a floor as a wall, then you get the wrong entities, the wrong information. So I see as a defined thing about what entities and what information. A classification system. I heard that it's not really available now, but start using one. So you can filter your information over different objects. So this is all the piling, this is all the floors, this is all the windows. So we don't accept duplicates and intersections in a model for obvious